All right, so the last couple of class times we were looking at kind of exponents and logarithms and what relationship they have to each other. And so today we're going to use those relationships and the rules we've established to solve equations. In other words, you're actually going to be finding out what x or whatever the variable we're using will be. So we're going to start off with what we're probably more comfortable with. So we're going to start off with exponential functions or equations. So if we know that b to the m power is the same as b to the n power, okay, then m must equal n. In other words, it's kind of this logic. Since the bases are equal, and we know that left side and right side are equal because of the equal sign, then the exponents are equal too. Okay, so let me just give you a real basic example of why this works. If I told you that 2 to the third power was the same as 2 to the x power, what's the only way for the left and the right side to be equal? What would x have to be? 3. Yeah, x would have to be 3, right? That's the only option. So, in other words, since the bases are equal, then the exponents must be also. So that's the first type of exponential equation we're going to start off with, where we have that the left and the right side have the same base. And we're going to try to figure out what x must be. Okay, so what do you notice is already true about the bases? Yeah, the bases are already equal. So that means that 2x plus 3, the exponent on the left, and 5, the exponent on the right, must be the same also. We already kind of set them equal, but I'm just trying to say that's the logic that we're using there. So let's try to solve for x. So we're going to subtract 3 from both sides, and we'll get 2x equals 2. And then divide both sides by 2. So x is 1. Okay, so that type is pretty easy when the bases already are the same. Sometimes the bases won't be the same at the beginning, but maybe we can make some changes that will make them the same. So if the bases aren't the same, try to change one or both sides. So that the bases can be the same. And in order to do this, you're going to have to know your rules for exponents pretty well, okay? But I'm going to underline this word try because, just to be honest, it's only going to work with really specific certain kinds of questions. So just know that we're going to go with this method when we can, but it's not always going to work. So let's take one like this. Now notice the understood exponent for 64 is 1, right? But I don't even care about that because I'm not allowed to set the exponents equal to each other. Why not? Yeah, the bases aren't the same yet, okay? So maybe we could rewrite this as a power of 4. Now I'm not talking about 4 times something. When I say a power of, it has to be like 4 raised to a power of something. Okay, so how many 4s does it take to multiply by each other to get to 64? Like 4 times 4, 2 of them is only 16, right? So how many do we need to get to 64? 4 times 4 times 4, right? 3 of them. So we could rewrite 64 as 4 cubed. Notice I'm not doing anything to the left because it already is a power of 4. Okay, so now what do you notice that wasn't true before? Now the bases are equal. So we can set 2x minus 1 equal to 3, and then solve from there, right? So we'll add 1 to both sides, and we'll get 2x equals 4. And then we'll divide both sides by 2. So x must have been what then? X is 2, right? 4 divided by 2 is 2. Okay. Note that these can be checked on your calculator. I'm not going to show you this for everyone, but kind of while you're finishing that up, you can kind of look up at my calculator on the screen. So if I do 2 raised to the 2 times 2 minus 1 power, right? Notice I inserted 2 in for x because that's what I think x is. And you just make sure, and that didn't work, right? Because what did I do wrong, by the way? What did I enter wrong? It's not 2, it's supposed to be what? What's the base supposed to be? 4, right? So don't make little stupid calculator errors like that. I don't know why I just pushed graph. It's a Monday for sure. All right, quit. We don't need you to graph. There we go. All right, so notice now that I entered the right thing, right, it equals 64. Okay, so you can verify that you're right in these equations, and hopefully you will, especially with the exponential ones. So you just verify that left side equals right side. All right, so let's do a few more where maybe the rewrite step is actually kind of a little bit of a challenge. Okay, so I definitely cannot set the exponents equal to each other because my bases aren't the same. But I look at 25 and I realize to myself, if it were just 25, I could do this pretty easy, right? If it were just 25, what would the power be? 2, right? 5 times 5 is 25, okay? But it's 1 over 25, so do we remember what kind of exponents give us fractions? Negative exponents. So we want to rewrite this as a power of 5, So if I want to rewrite 1 over 25, it's just going to be 5 to the negative 2, okay? Because regular old 25 would have been 5 squared, but because it's a fraction, it's negative powers. Notice again, the left-hand side I don't really mess with. So now what can we say? Now the bases are what? Now the bases are equal. So I can set 2x minus 1 equal to negative 2, and just be wary of your signs. So we'll add 1 to both sides. And we'll get 2x equals negative 1. And then we'll divide both sides by 2. So we end up getting that x is negative 1/2. Okay, so if we were going to check this one on the calculator, we could just do just what we did before. 5 raised to the 2 times negative 1/2 minus 1 power. So all I'm doing is typing in what the left-hand side is with the negative 1/2 stuck in. And notice I get 0.04, and then you just match that with what the right-hand, or sorry, the right-hand side was. And notice they're the same, right? It doesn't even really matter what each one is. They just need to be what to each other? Equal. Okay, so if you've done it right, the left side and the right side are equal like we're saying they are. All right, so I'm going to try to do kind of a variety here of problems that you might expect on your homework. So what about 7 to the x minus 2 over 6 power equals the square root of 7? Make sure that x minus 2 over 6 is in the exponent spot. That's where it should be. So again, we're not ready to do anything until we rewrite this guy. Okay, we need to rewrite this as a power of 7. Okay, so we just talked about in example 3 that fractions are negative exponents. What kind of exponents are roots? Moving forward, you are definitely going to need to know what fractions are as far as roots go, or fractions are as far as exponents go, but also roots. Yes?
So that fraction up there that you gave me the negative 2, so 1/25, or it was something else for the exponent?
I'm not sure what you're asking me, but the 1 over 25, yes, if you plug in negative 1/2 here, you're going to get 1 over 25.
No, I was talking about the negative 2 under the 1 over 25 in the exponent. Or is that not
5 to the negative 2 power is 1 over 25.
All right,
Yeah, we're rewriting it. All right, so how do we rewrite this guy? How do we rewrite square roots? So square roots, remember, if you're not sure, you need to review this because you're going to need to just kind of moving forward know it. Square roots or roots at all are fractional exponents. If it's square root, it's 1/2 power. What if it's cube root? 1/3 power. If it's fourth root, it's 1/4 power. So all square roots just mean whatever the number is to the 1/2 power. So I've got this. Okay, so notice now my bases are equal just like before. So I'm going to set x minus 2 over 6 equal to 1/2. Okay, so if you're not sure what to do here, when you have a fraction equal to another fraction, you can cross multiply to get it out of fraction form. So what that means is you do this times this equals that times that. Okay, it's cross multiplication. So in other words, we get 2 times x minus 2, notice I used parentheses, equals 6 times 1. So it's important to use parentheses because this 2 actually needs to multiply by both things. So this is 2x minus 4 equals 6, right? 6 times 1 is 6. And then we should just be able to solve as normal. So add 4 to both sides, and we get 2x equals 10. And so divide by 2, and we get x equals 5. Okay, so it's this step that you're going to need to make sure that you can do. It's the rewrite step that's important. Everything else, I think, follows pretty naturally from that. But if you can't rewrite things like fractions and can't rewrite things like roots, then you're going to be dead in the water with these problems. So that's the first thing that you need to make sure you tackle. You know, do I know how to rewrite things in exponent form, even when they're a little unusual? So let's look at a problem involving E. Don't let the fact that it's E freak you out, because remember, we're not even really doing anything with the base, right? We're just trying to get the bases equal so that we can set the exponents equal to each other. So remember, E is that number 2.718281828, but it doesn't even really matter. So what would I want to do with this, just like I have been doing before? Yeah, I want to make it match, right? So I want to rewrite as a power of E. So don't make this harder than it is, right? If it's a fraction, what kind of exponent is it for sure? It's negative, right? So I don't even need to change anything other than I know that the 2x exponent originally is now negative because it was a fraction. And then I can just rewrite the left side. So now, just like before, notice the bases are equal. So I can set x plus 4 equal to negative 2x. Okay. Just be really sure that you keep track of your signs. So I'm going to subtract x from both sides just so it's on a different side from this number 4. So I get negative 3x over here, and then I would divide by negative 3. So it looks like I get x equals negative 4/3. So this would be a great one to check because it's not going to give us something pleasant on either side. Okay, so let me show you what I mean by it's not going to give you anything pleasant. So we're going to plug in the left and the right side, and we don't care what we get, we just care that they're what to each other? Equal. Okay, so we're going to do e raised to the negative 4/3 plus 4 power, right? Because I'm copying down what I have here. And I'm going to get 14 point blah, blah, blah. I don't even care what it is, okay? But I want to compare that with what I get here, right? So let's try that. So 1 divided by e to the 2 times negative 4/3 power. So notice in both cases, I just plugged in what I think x is for my x values on both sides. And notice I get the same 14 point blah, blah, blah number, right? So it doesn't matter what you get, you're just trying to verify that they're the same as each other. Okay, so that lets you know that you're good to go and that you've done it correctly. All right, so what about this one? 9 to the x power equals 27. So this one's actually probably the most challenging one we've done so far. Because actually I'm not going to be able to write 27 as a power of 9. It's 9 times 3, but that's not what I'm asking you to do. I'm asking you to do exponents. Okay, so we're probably going to need to rewrite both of these. So we need to think of a base that would work for both 9 and 27, right? What's a base that would cover both 9 and 27? 3, right? So we need to rewrite both in terms of powers of 3. So I'm going to do the easy side first. I'm going to do 27 first. So what power of 3 is 27? Third, right? So it's 3 to the third power. So I'm going to do that. Okay. This side's a little more challenging because it's got the 9, but then it's raised to the x power. So let's just work on the 9 part. What would 9 be if it was just 9? It would be 3 to what power? 2, right? But then you still have to raise it to that x power. But then this is just power rule for exponents, right? Which just says we're allowed to do a power raised to a second power if we multiply the exponents. So this is just 3 to the 2x power, and this is 3 cubed. Okay, so now we're to the point where we're ready to go. How come? Now the bases are equal. So now that the bases are equal, we can set what?
2x equal to 3.
Yeah, set 2x equal to 3.
So we basically, like when the base is equal, we basically just like solve for the exponents.
Mm-hmm. Yep, because when the bases are equal, the exponents are too. We don't really drop the exponent or the bases, we just don't worry about them because they're already the same. So we worry about the part that needs to be the same after that. And then if we divide both sides by 2, we'll get our answer, which is 3/2. Okay. So again, while you're finishing that up, this is an easy one to check, so let's go ahead and check it. Is 9 raised to the 3/2 power equal to 27 like we think it should be? And notice that it is. Okay. So far, every question we've done that looks like this, we've been able to check on our calculator, right? That means when you encounter these questions on the test, you should be able to know if you did it right, if you'll take a couple seconds to plug it in your calculator, and I hope that you will. All right, so let's do one more like that, and then we're going to move on to something else. So to be honest, I think if you can solve this next one, you can do any of the ones of this type that you can expect to see on MyLab. So I always put a question kind of like this on test 3, and I always have students just be like, oh, I'm just going to set x plus 3 equal to x minus 1, okay? Which seems easy enough, right? Why is that wrong?
The bases aren't equal.
The bases aren't the same. So you shouldn't be moving on to step 2 when step 1 isn't right, correct? So step 1 is to make sure the bases are the same. So I am going to need to rewrite both of these, but we need to think about like what the base needs to be. Okay, because 16 could be 4, right? But notice we can't write 8 as a power of 4. It's 4 times 2, but it's not 4 raised to a power, right? 4 to the first is 4, 4 squared is 16. But what's a number that might work for both 8 and 16 if 4 is not going to work? Yeah, we want to go smaller, right? So we're going to rewrite both in terms of powers of 2. Okay, so we're just going to take this baby steps at a time. So first we're going to work on the 8 part. So what power of 2 is 8? Like how many 2's do you need to multiply by each other to get you to 8? 3, right? So 2 times 2 times 2, right? So I'm going to rewrite this as 2 cubed, but then I still have to include the x plus 3 power. So all I did in that step is just rewrite the 8 part alone, okay? So doing the same process, what would I do on the right side? I would rewrite 16 as 2 to what power? So how many 2's does it take to multiply by each other to get you to 16? One more, right? 4? Okay, so it'd be 2 to the 4th power. And then again, we still have our x minus 1 power. So the trick here is this is power rule of exponents. You just need to make sure that when you multiply both of the exponents, or both of the pairs of exponents rather, that you use distributive property, because this is actually 2 to the 3x plus 9 power, because you do 3 times x and 3 times 9. So using that same logic, what's the right-hand side going to look like? 2 to what power? 4x minus 4, good. Okay. If you can get here, this is the difficult step. Okay, the rewriting is the most difficult because now you have a problem just like the other ones we've been looking at for a while, right? So now what do you notice again? We've written this down a lot of times. Yeah, the bases are now equal. So now I can set 3x plus 9 equal to 4x minus 4. And just solve from there, right? So I'm going to move this 3x this way. I'm going to move the 4 to the other side. So notice these are going to go away, right? And I'm just going to get 13 on this side equals x. And that's my answer. All right, so let's check it. And again, I just want you to see that it doesn't matter what crazy answer you get on the left. You're just trying to make sure you get the same crazy answer on the right. So we're going to do 8 raised to the 13 plus 3 power. And notice, if you don't know what this is, that E indicates that this number is ginormous. And it should be ginormous, right? It's 8 to the 16th power. So what does that mean? 8 times itself, how many times? 16 times. It's huge. Okay, so this is like the calculator's version of this number's too big for me, and I'm going to give it to you in scientific notation. But we don't care what it is, right? We just are trying to make sure what? That we get the same thing on the other side, right? So it's 16 raised to the 13 minus 1 power, okay? And notice, as goofy as that answer is, it's the same goofy on both sides, right? And that's what we were trying to show, okay? There's kind of a glare there, but they are the same. Here we go. So if possible, we try to get the bases to be the same. If they're not the same already, we try to rewrite so that they have the same base, okay? But I don't think it's too much of a stretch to maybe think about what if there's some times you're not going to be able to get the base the same. So what about when you can't easily rewrite them to have the same base? So an example of that would be 2 to the x power equals 35. Like, no matter how hard we try, yes?
You might want to add a but between what and when for the people who are watching the video.
But what about is what I meant to say there. What about when you can't? Yeah. Okay. All right, so what do we do? Like, could you rewrite 35 as a power of 2? Like, there's no way, right? Because 2 is an even number, and so you should be getting even answers, right? So there's no way to do it nicely, right? Because 2 times 2 is 4, times another one is 8, 16, 32, and then we go to 64, right? We skip right over 35, okay? So when you can't get the bases to be the same, I'm going to show you a second process. This is actually one of the main reasons we teach y'all logarithms to begin with. Okay, so when you can't get the bases to be the same, we're going to use logarithms to solve instead. And we'll come back to this question, but I want to list for you some steps on what to do. So the steps for solving exponential equations when the bases just won't be the same no matter what we try. So the first step is you want to isolate the exponential term. In other words, you want to get it all by itself. Okay, and the exponential term, we'll talk about it, but this is the exponential term, both parts. It's 2 to the x power. That would be the exponential term in the previous example. Step number 2 is our new process. You're going to take the logarithm of both sides. Because a long time ago in algebra we learned we can do pretty much whatever we want to the right side as long as we do what? the same thing to the left, right? We can add 2 to the left as long as we do the same thing to the right. We can multiply the right by 10 as long as we do the same thing to the left, right? So as long as we do the same thing to both sides, we're allowed to do just about anything. So just a quick reminder from last week, remember we had 2 forms of the logarithm, right? We had log log and we had ln, okay? So either logarithm is what I'm trying to say. So I'm going to put a star by this step. This is actually the most important step out of the whole method. So step number 3 is, now that you have a logarithm, you're going to use the power rule that we talked about last week. You're going to use the power rule of logarithms to move the exponent to the front of the term. Last but not least, you're going to solve for x and check your answer. The checking of your answer is optional, but like I've already said today, it just helps you kind of move on and know that you did the problem right, so you don't have to second guess yourself. So let's take that problem that we just said we wouldn't be able to rewrite and see if we can use the secondary method to solve it instead. So remember, we already said we're not going to be able to rewrite 35 as a power of 2, not easily anyway. So the first thing is we isolate this guy, but notice it's already isolated, right? So if there were other numbers, we would move them over, but there's not, okay? So what we're going to do, I'm going to rewrite it just so that my notes kind of look complete, but I'm going to take the log of both sides. This is not multiplying both sides by log. It's more like an action. It's a verb. It's taking the logarithm of both sides. And the reason we're going to do that is because the power rule for logarithms tells us what about the exponent? We get to move it where? Move to the front, okay? So this becomes x times the log of 2 equals the log of 35. And now we're actually down to one more step and we have this thing solved, right? Log of 2 is just a number. It's an unpleasant number. It's a decimal number. But what do you do when you're multiplying by a number that you'd rather not have there? Like, what's the opposite of multiplication? Division. So we're just going to divide by log of 2 because, like I said, it's just a number. And so then we're going to enter, or have something we can enter in the calculator. So we've got log of 35 over log of 2. And then let's punch that in the calculator, okay? So it's log of 35 divided by log of 2. Okay, so note, let's do it to 2 decimal places. That's about 5.13. So I'm going to circle both of these answers. Okay, I want the exact answer, which is the log of 35 over the log of 2 part, but then we're also going to kind of approximate what the answer was as well. All right, so let's check it and make sure that that's right. Okay, so let's go back to the original problem. So what are we basically saying if our answer is 5.13? We're saying that 2 to the 5.13 power should be awfully close to what number? Well, no, that's our answer. That's our exponent, right? What would 2 to that power have to be really close to? 35, right? So let's check it. So 2 raised to the 5.13 power is not exactly 35. How come it's not exact? Because what did we do to get to 5.13 anyway? We rounded it, right? But it's pretty close, right? It shows us that we're on the right track. Okay, so that's what the check step looks like. All right, so what logarithms allow us to do is it allows us to get this x term out of the exponent spot using power rule. That's why we really learn logarithms, essentially. Okay, it allows us to solve when the unknown is kind of in a weird spot, and it allows us to move it to a spot that's more manageable. All right, so let's take another one. By the way, if you were for some reason tempted to divide by 10, you cannot do that, okay? 10 to the x power is like a partnership. So it's an exponent, and you're not supposed to be dividing before you handle exponents. So don't do that. By the way, if you did do that, you'd have an exponent chilling up there by itself, right? Do you ever see an exponent floating without a number below it? You shouldn't, right? So don't divide by 10, you can't do that, okay? We also can't write 80 as a power of 10, right? It's 10 times 8, but that doesn't matter, right? It's not 10 to a power, okay? So before we move along with this, what's 10 to the first power? 10, right? So that's too small, right? What's 10 squared? What's 10 times 10? 100, right? And that's too big. So what do you guess our answer is going to be between then? If 1 is too small and 2 is too big, our answer is going to be what? Like between 1 and 2. It's going to be 1 point something, okay? So let's use our rules here. So I'm going to rewrite this with some space. So I'm going to take the logarithm of both sides. Now you can use either log log or ln. And I really don't care which one, but because it's a power of 10, I would definitely use log, because what's the understood base for log log? 10. So we do this because it's going to allow us to move the x up to the front. So we end up getting x times the log of 10 equals the log of 80. But to be honest with you, this is just 1. Because remember, log and powers of 10 are opposite operations, okay? So you end up just getting x equals the log of 80. And then that's something that could be plugged in your calculator. If you do plug it in, you'll get about 1.90. Okay, so just like we thought, what's our answer between? Just like we mentioned verbally before. It's between 1 and 2, right? In fact, it's closer to 2 because 80 is closer to 100 than it was to our 10 answer, right? So you can kind of reason it out that way. All right, so let's do some more of these. So again, I want you to solve for solve for x. So 3 times e to the 5x power equals 1977. Okay, we haven't really had one like this before, and I don't mean the e part. We haven't had one where there was another number kind of getting in the way. So what I mean by that is this is the exponential term, e raised to the power. So we're supposed to isolate it first. It wasn't an issue with the previous one. So what number needs to get out of there then? Nope, the 5 is going to have to stay because it's part of the exponent. Yeah, the 3 needs to go, right? So we're going to divide by 3 first before we ever start anything else. So this is going to give us e to the 5x equals 659 if you use your calculator. Okay, so now what? By the way, no way could I try to write 659 as a power of e, right? E is that ugly number by itself, so I don't even want to try to think about that. But I can take the what of both sides? I can take the log of both sides. Which log would it be best for me to use with ln, or with e? I just told you the answer. ln. So why would I want to use ln? Because what do ln and e do to each other? They cancel each other out. Okay. So a couple of things. This is going to move to the front, but also ln and e are going to get rid of each other. So we end up with just plain old 5x here, and then we have ln of 659 here. So we're almost there. We're almost to an answer because why? If we want to know what x is, what's the one number that needs to move now? 5 needs to move, right? So how do you get rid of a 5 if you're multiplying? Divide. So if I ask you for the exact answer, or if my lab does, it's the natural log of 659 over 5. Don't try to simplify. You can't simplify from within an ln. But if you plug this in the calculator, you're going to get about 1.30. Okay. So we haven't done this in a little bit, but how could I check my answer? Yeah, plug it in. So try to see, is 3 times e to the 5 times 1.30 power, is it close to 1977 or not? Okay, so let's see how close it is. So 3 times e raised to the 5 times 1.3. Okay, so I want you to see that it is not as close as maybe we would have liked it. It's not as close as some of the other ones were. Okay, and we didn't do anything wrong. So does anybody know why it's not as close?
Because E is like a weird number, like it's
That's a good guess. Not quite. That could be a little bit of it, but maybe not that much, okay? The reason is because this number was so big. Like, for instance, If my bank calls me and says we made a 1% error on your checking account, I'm gonna be like, I don't have much money, so I don't really care, right? What if they call Oprah and tell her they made a 1% error on her account? Would that be bigger? That would be a lot bigger, right? So in other words, a rounding issue means a lot more to big numbers than it does to smaller numbers. So just know that when your numbers are large, like in the thousands or even in the hundreds sometimes, when you check it, it won't be perfect, okay? It won't even be as close as what you would expect. When the numbers are smaller, you get much more accurate readings because rounding errors don't mean much to the smaller numbers, okay? All right, so let's do another one. So e to the 5x minus 3 power minus 2 equals 10,476. So I am not ready to do logarithms now. Why not? Yeah, I need to isolate this, right? Like this is my exponential term and it needs to be all by itself. So what do I need to do first? Add 2, do the opposite, right? So we were subtracting, so we'll add. So we've got e to the 5x minus 3 power equals 10,478. So I'm going to rewrite this just to leave myself some room. So now what? No way I could rewrite 10,478 as a power of e, so what am I going to do instead? Take the log of both sides, right? And I can do either one, but when it's e, I want to use ln for sure. Okay, and I want to use ln because what do they do to each other, ln and e? Cancel, and it allows me to move this guy to the front. Okay, so I end up getting 5x minus 3 equals the natural log of 10,478. So I'm not quite there. What do I need to do now? I need to get x by itself, right? I'm trying to solve for x. So now what would I do? Probably add 3 to both sides, right? Do not combine terms that are part of a log. So leave this as 10,478 and then just say it's being added, 3 is being added to it. You're not allowed to make that 10,481 if you're tempted to do that. So just leave it alone. And then what would be the last step if I wanted to x by itself? Divide by 5. So we may not love the way this answer looks, but this answer is completely able to be plugged in the calculator, and your calculator can handle this with no issues whatsoever. So we're going to do ln of 10,478. Make sure you close your parentheses to let the calculator know you're done with the log part. Okay, plus 3. But I am going to need parentheses around the top because the top has what? More than one piece, right? So notice I went in and inserted parentheses around the numerator. Okay, so I'm going to go ahead and insert them here so you see what we did if you work this later on. And then you would divide by 5. So you get about 2.45. So
if you would have like put that in as a fraction, like click log and then like a fraction and put a number there, would you still need a parentheses?
Well, you wouldn't do log of a fraction. It still needs to be log of just the 10,478. You could do the fraction button and do the whole top over the whole bottom, if that's what you mean.
Yeah, that's what I mean.
Yeah, you can do that. All right, so we're not going to do it, but what would happen if you checked this? Is it going to be close or maybe a little off? It's going to be a little off because notice we have 10,476, right? So the bigger the number is, the more it's going to be off when you try to check it. Doesn't mean it's not worth checking. It just means we got to be aware that it's not going to be perfect. All right, so let's do some problems that are not E-based to make sure we can do those. So 7 to the 0.3x plus 1 power equals 100 or 813. So notice, just like I said before, I can't think in my mind what I could rewrite 7 or 813 to be a power of 7. I can't think of that. Okay. So what am I going to do instead? Take the log of both sides, but this time notice there's really no preference, right? When it's E, you definitely want to use which log? ln. When it's 10, you definitely want to use which log? log, right, regular log. But when it's another number, you can just pick one. So I'm just going to switch back to log just to remind you that you have more than one option. Okay, but it would work the same no matter what. What's the point of doing log or ln for that matter? What's the whole point in doing it? That it's going to move this where? To the front. That's why we want to use the log. Otherwise, why would we be trying to make a problem more difficult? So the point is we're actually trying to make it less difficult by moving that exponent to the front. So there's a couple of ways to do this. Okay, so I'm going to do the way that I think makes the most sense. So I'm trying to get x by itself, so the first thing I'm going to do is get rid of the log and move it over. Notice I am multiplying originally, so I divide to get rid of it. So that's going to get rid of this, leaving me with 0.3 x plus 1 equals log of 813 over log of 7. Okay, so ignore the right. What would I do to the left if I want to get that x all by itself? What do I need to get rid of first? The 1, so how do I do that? Just subtract by 1, right? Whatever I do to one side, I have to do the same thing to the other. So that's going to give me this. Okay, don't try to get fancy with it. You're not allowed to simplify stuff that's a part of a log, so just leave it as it is. Okay, and then there'll just honestly be one more step. Okay, so what's the one more step? If I want x all alone, what's the final step? I need to divide by the 0.3. So I understand that you might not think this is the most satisfying answer in the world, but just know that the calculator can handle this just like it can 2 plus 2. Okay, so you're just going to punch this in the calculator. What part would have to have a parentheses around it? Because it definitely has more than one piece. The top or the bottom? The top has more than one piece, so put that in before you use your calculator. Okay, so you just might want to, if you don't have a calculator with you today, you just might want to check them later. Okay, but you should get 8.14. And then if you want to, what will you do to make sure you did it right? Plug it back in and check it. Just know that it's not going to be perfect, right, because the 813 is kind of large. Okay. So enter it in just like that, and you should be able to get the 8.14 that I did there. Also, just kind of a side note, make sure you're rounding and not just cutting off the decimal. So MyLab will tell you round to 2 or 3 decimal places, and make sure you look at the digit past what it tells you to round so you know if you need to bump it up or leave it the same. Okay, so this is going to be the last one of exponential equations. This is also probably something you'll see on test 3, and for the past, I don't know, at least 10 semesters, this has been on the final also. So I'm going to go ahead and put a star by this equation or this example because I think you will see it again on the final exam. If the last 5 years are any indication, at least that long, they've had a question kind of like this on the final. So notice, we cannot not set the exponents equal to each other. Why not? The bases are not the same, right? In fact, can we even get the bases the same? Can you rewrite 5 or 3 as the other one? Can't, right? So what are we going to use instead? We're going to use the logs instead. So I'm going to rewrite this with a little bit of room. Okay, so it doesn't matter which log, right? Because I don't have I don't have E or 10 or anything like that. So I'm going to use ln, but just know you could have used either. So notice, actually, what's it going to do on both sides? What's it going to do with the exponents on both sides? It's going to move them to the front. So make sure you use parentheses. So you're going to end up with 2x plus 3 times ln of 5 on the left. And you're going to end up with x minus 1 times ln of 3 on the right. So we just want to get the x's by itself. Just notice there's x's on both sides. So that's where it's going to be a little bit of a challenge. So I am going to have to use distributive property here on both sides. Okay, so in other words, this ln of 5 is being multiplied by both of these things. So I'm going to just go ahead and write it out just like it is. 2x times ln of 5 plus 3 times ln of 5. Notice both things got the ln of 5. And the same thing's going to happen on the right. I'm going to get x times ln of 3. Both things are going to get the ln of 3. ln of 3 times 1 is just itself. So I know these are weird, but what you have to try to do is muddle through the mess to try to figure out what your goal is, right? Your goal is to get these guys by themselves. Your goal is to find out where x is or what x is, okay? So if you can kind of keep that goal in mind, it's really helpful. So I'm going to move this term over here so that it's paired with the other term involving x. And then I'm going to move the thing that doesn't have an x in it at all to the opposite side. So notice that's going to make that go away. So now I've got 2x ln of 5 minus x ln of 3 on the left. And then I've got the two things that don't even have x's in them at all on the right. So now what you can do is notice that these are not like terms. I can't combine them or anything like that, but I do have an x in each of them, so I'm going to go ahead and factor / divide out an x. And if I do, notice I'll get 2 ln of 5 on the first term and ln of 3 on the second term. The right side's not really changing, so I'll just leave that alone. So believe it or not, we're actually one step from being at the answer. How come? If I want to get x all by itself, this is x times a bunch of mess. Okay, so how do I get rid of times a bunch of mess? What's the opposite of multiplying? Dividing. So I'm just going to divide by the whole entire thing just as it looks. The opposite of multiplication is division, so I'm going to use that to my advantage. Just make sure that whatever you do to the left, what do you also need to do? Same thing to the right. So that's gone and that's gone. So this is one of those times where it doesn't leave you with maybe a very satisfying answer, but it does leave you with an answer that your calculator can handle. So you get this on top and this on bottom. And you're not going to get fancy with it. You're not going to try to cancel anything out. You can't really do that with logs anyway. We're just going to punch it in the calculator, okay? Just make sure when you do more than one piece and more than one piece, so they both definitely need their own set of parentheses. So it's going to be negative ln of 3 minus 3 ln of 5. Make sure if you didn't bring a calculator today that later on you practice punching this in. It's not the same as watching me do it. Doing it yourself is not the same as just watching someone else do it. 2 times ln of 5 minus ln of 3. And then notice I closed the parentheses for the bottom. I have parentheses around the top and the bottom. So I end up getting about negative 0.280 if I round. Okay, so let's talk about what the check step would look like for this one. We haven't talked about it every time, okay, but what would the check step look like? You would go back to the original and you would do what? Here's the original. I'll slide it back down if you're still writing in a minute. So what would I do with the check step? I would see if 5 to the 2 times negative 2.8 plus 3 power, see if that is pretty close to 3 to the negative 2.8 minus 1 power. Okay, it's not going to be exact, right, because I rounded, but it should be pretty close. Okay, it should be in the ballpark. So let's check it. So 5 to the 2 times negative 2.8 plus 3 power. I don't even care what I get. What am I just trying to show? That they're close to the same in this case, right? So then I do 3 raised to the negative 2.8 minus 1 power, okay? And notice they're not exactly the same, but I think they're close enough where I would be confident that I did it right? They're both 0.015, so they're pretty close, okay? so before we move on to something else, what do you first try when you have an exponential equation? First, you try to get the what to be the same? The basis to be the same. But when that can't happen, what do we use to kind of force our hand? We use logs, right? Either ln or you use log, log, right? Generally speaking, use either one, but what would you use for sure when it's e? ln, and what do you use for sure when it's 10 to raise to a power? Log, and then otherwise you can use either one. Okay, so we could have used log log on this one. It wouldn't have made a difference. We would have gotten the same final answer. Yes?
So if you're gonna use log and it's not 10, that means you have to divide.
Yeah, you have to like move it to the front, and then you'd still have log of whatever that is.
Okay.
So literally, if you would have used log log, it would look exactly like this, just everywhere there's an ln, there'd be an log. Like every step even would have been the same.
Okay. And then if it's a problem where you can get the bases equal, is it gonna be pretty noticeable that like you can?
I mean, for the most part, yeah.
Okay.
It'll be like powers of 2 and 3, things that
Very
you're
easy.
pretty obvious, yeah. It's not gonna be like powers of 17 or something, so, for the most part. Okay, so let's look at logarithmic equations. So, now, admittedly, we're not as comfortable with these, and I get that. But if you have the log base b of x, and it's equal to the log base b of y, then x must equal y. Okay. What do you notice is kind of the word logic you could use? What's already the same, just kind of like it was for the exponent form? The bases are already the same, so what has to be true then? What we're taking the log of has to be the same. So it's kind of the same logic, so let's go ahead and write that out. So if the bases are the same, so if the bases of the logarithms are the same, then what you're taking the log of is also going to be the same. So it's still, if the bases are the same, the rest of it's the same. It's just admittedly a different format. So we've already talked about this, I think, but just to make sure, you can't take the logarithm of 0 or any negative number. If you try to do it, it's going to give you an error on the calculator. But let's talk about why it really doesn't work at its core. So let's just try one that would not work on our calculator, and we'll talk about why. So it might have been a minute, but what is this really saying? What did I tell you last week was the answer to every logarithm equation I would ever ask you for? What's the answer in general to a log question? You're trying to find the what part of the problem? You're trying to find the exponent, remember that? So logs are asking you to find the exponent, okay? What's the understood base for log? 10. So if we rewrite and we think about what it's really asking, okay? So this is saying, what do I need to raise 10 to the power of to give me 100? And notice this is not possible no matter how hard I try, right? Or sorry, negative 100. I'm never going to get negative 100 even when I raise 10 to any power I want, because even if I raise 10 to a negative power, I get fractions. Okay, I don't get a negative number. So just kind of keep that in mind as we go for solving logarithmic equations. So solving logarithmic equations when the bases are the same. Because by the way, it doesn't work at all when the bases aren't the same. You can't combine them whatsoever. So the first thing is I want you to use a rule of logarithms to simplify when possible. So we're going to do some examples of these two. How many rules of logs were there? 3, right? Power, product, and quotient, right? The same number that there were for exponents. 3 rules. Number 2, I'm going to put a star by this. If you can get this rule, then you usually get the hardest part of the problem done. Rewrite it in exponential form whenever you can. In other words, you're going to have to remember, where do things go? How do I rewrite a log to an exponent? Okay. And then last but not least, you're going to solve for x. And definitely check your answer. So I know I've been saying that a couple of times, but I'm going to underline it here. Okay. You have to make sure that there are no logs of 0 or negative numbers. And that actually happens a lot here. So you're going to need to be especially careful about that.